Hey everybody, welcome. I'm going to run through our homework quiz here real quick. There's been some requests for the video, so I'm glad you're actually watching it. This will probably be a really long video, so I apologize because I'm going to run through it in its entirety instead of kind of broken up by chunks. But if I get some time, I'll try to timestamp the questions so you can find it and send the feedback. Otherwise, just keep skipping. I'll go in chronological order, at least, of the homework quiz. ESL, make sure you recognize I'm going to go through the full homework quiz that fifth period has. You will not have a handful of those questions. So if you see something like, I don't see that on my homework quiz, it's because you don't. So just skip over those questions and we'll get started. So starting here with what tools and resources you have, I want to remind you that I've built some Desmos tools for exploration and just to play around with. So if you're like still uncomfortable with how some of these work and behave, feel free to click on any of these. They'll open up with kind of a pre-built triangle, and you can play around with it and see how, like, for example, here, your circumcenter is changing. The thing that hopefully you will notice as you're playing with this and remember, you're like, oh yeah, that's right. The circumcenter is equal distant to all three of our vertices. So you might use this as kind of a good friendly reminder of that property, but you can play around with it, okay? This is just a tool, so feel free to use any of those four. If you want additional information on the note card that we built, I have not quite posted it, but it will be in here shortly along with this video. Underneath your Google Meet recordings of class, I will put together one there that is a recording of me building the note card, which we did in class on Monday and Tuesday this week. So, and I'll probably actually attach a link to this video in that as well. So you have all of your information on how to build that note card. So hopefully that will be a good thing for you. But let's jump into the homework quiz underneath work for today. Homework quiz. As always, please make sure you throw your name in. The first section is just some vocabulary, and so use your notes or kind of follow along with this. A mid-segment, this is when we connect two of the midpoints and it creates that mid-segment. Again, this is something that's on the vocab for everybody, but ESL, you're not going to really have any question on this. However, I'm going to, like I said, do a quick deeper dive here. So for my fifth period students, you will want to know that this distance of the mid-segment, whatever that is going to be half of the base that's across from it. So if I know the base, then I can chop it in half to find the mid-segment. If I know the mid-segment, I can double it to go find the base. The other thing that's kind of important and might be useful if you ever see something like this on an SAT or ACT is that those two lines are parallel. So all of our parallel line properties from Unit 3 will also apply here, okay? So that's your mid-segment. This is the connection of your midpoints. Perpendicular bisector, you've got a line, segment, or ray that divides a segment into two equal or congruent parts, right? That's our bisector, two equal parts or congruent. And then it's perpendicular, so it must be perpendicular to that segment as well. So congruent and perpendicular. Angle bisector, again, bisector, cutting it into two equal parts. So, or congruent is the other word we're looking for there. So two congruent parts. Median, this is the one where we cut right down the middle. I always try to remember, like driving on the road and you've got those planter boxes or the trees in the middle of the road. Median goes to the middle. So you're connecting a vertex to the midpoint. So we cut right down the middle of that triangle. Altitude, I think of altitude sickness. And so that's like elevation or height. And so that's from a point, our vertex dropped straight down to the ground so that it meets at a perpendicular. Again, this looks kind of like this. So it hits at that 90 degrees from the vertex to perpendicular, which is your 90-degree angle, right? So Circumcenter. So now here's your 4 centers we are looking at. Circumcenter is the one where we are looking for the intersection of our perpendicular bisectors. Again, use your note card for this. You will have it for the test. Try not to overthink this. Just rep this a little bit. But the circumcenter is the one where you're in the center of a circumscribed circle and you're equal distant to each vertice. In-center is the inscribed circle, so we're equal distance to all 3 sides. This is created with our angle bisector. Centroid, this is that center of balance or center of gravity. That was the pinwheel we showed in class. So a point at which all 3 medians intersect, kind of chopping it through the middle. This also is the one where it creates that 2-to-1 ratio. We'll talk about that here later. And then the orthocenter is all of your altitudes. All right, jumping into the actual math piece of this. Again, for my ESL students, go ahead and skip through these first couple questions. You will not have this on your test or on your homework quiz. So skip ahead probably about 3-4 minutes. So this is the mid segment. Again, I know that the PR, for example, this full distance, that base, if this is 46, then I know LM, the mid segment across from it, is half that distance. So I would know this part is 23, okay? Similarly, with all of these, if I've got PQ is 40, so that's this full distance, that part would be half of it. So this would be 20. And then we've got LN. So this time I have the mid segment. So then I know if this part here is 17, then I must double that length to get 34. That's kind of my full piece over here. The other thing that's kind of fun is, again, remember, these are mid segments or midpoints. So this is getting split into 2 equal parts. This is 17 and 17. And without going into too much detail, this actually is a little bit of a preview of what we're going to see with quadrilaterals and parallelograms, that you'll actually see that this is congruent to this, and it has to do with that idea that I talked about, how those lines are actually parallel. So not going to go too deep in that. We'll touch more on that when we get into the quadrilateral unit here in a couple. All right. So like I've shown you kind of all year, I like to just get all the information onto the triangle and then go fill in the answer boxes, just because sometimes I'll get lost if I'm bouncing back and forth. So let's just go fill in our answers now. So L to M is that part. So that was 23. M to N is this part. So that's 20. Q to R is this part. So that's our 34. And then M to R is the shorter part of that, which is the 17. Okay. All right, this one's a little bit more algebraic, same idea. I know my mid segment is half that of the full one. So if I take my mid segment and double it, multiply by 2, it will be equal to the base 17x minus 18. So 14x equals 17x minus 18. I like keeping my x's positive, so I'm going to subtract the 14x over. And then I'm going to add the 18. You might choose to subtract the 17x, and that's totally fine too. For my own personal, I find that I make less errors and I lose my negatives a whole lot less often if I keep my x's positive, so I'm not dividing later by negative numbers. Okay, so I've got my 3x equals 18, divide by the 3, x is equal to 6. Okay, you can always go back, plug it in, and check your work if you've got the extra time to do that on your test, for example. Okay, perpendicular bisectors. If you have a triangle and you drop a perpendicular bisector, this kind of goes back to our triangle congruency stuff. You now have a side, and you know this is perpendicular, so you have side, angle, side, and you know that these two triangles in their entirety are congruent to each other. So if the triangles are congruent, then the parts are congruent. So you know this is equal to this. Just set them up to say they're equal and do your algebra. So I'm going to subtract 7x from both sides, add 48 to both sides, divide by 6, x will equal 12. Angle bisectors, we're splitting this shape down the middle. Well, more specifically, we're splitting just this angle into two parts. But what you're going to notice here, again, is you have a right angle that's given to us. You have another angle, and then this side that's down the middle it's sharing is congruent to itself by a reflexive property. So now you have angle, angle, side, which proves to us that this triangle here is congruent to this triangle here. This is actually helpful when we get to the incenter, because the incenter will create a whole bunch of these little triangle pods that we're looking at right now separately. And so keep this in mind as you move into that, because it's what further proves that those consecutive parts of the triangle are going to be congruent to each other. But more importantly, for this specific example, those two are congruent, so you can set them equal. So 9x minus 5 is equal to 4x plus 30. 5x equals 35, x equals 7. Cool. All right, now we're jumping back in. If you were with my ESL group, come on back in. Here's where we're at, okay? We're all picking back up here with the centers, our centroid. Keep in mind some of your properties that you have. The first property is because a median is a midpoint, you know that you've got these pieces that are all congruent because the midpoints are going to, the sides are split in half, okay, or a 1-to-1 ratio, right? They're equal to each other, the two parts. And then the other part, and we'll use this more, I think, on the second question, if I remember correctly, these medians are getting split such that you have a 1-to-2 ratio, right? The small part here, let's call it x, is then going to have a ratio to the longer part from the centroid to the vertex of 2x. So it's basically 1/3, 2/3 how they split apart. Now in this, lost it, where'd it go? Now in this particular example, we've got JK is 22, so that's this full distance. If this is 22, and this is split into two equal parts, you know each part must be 11. So K to M would be 11. J to M, if it asked us, that would also be 11. Next question off of KN is 13. K to N is 13. We know that these are equal parts, so N to L is also 13. And then we would know this full distance, K to L, is 26. OL is 18. Again, these are equal parts here, so JO is 18. And its full distance there would be 36 for JL. Okay. These are, I think, the easier questions. We've done a lot of this with the midpoint stuff, so hopefully you feel familiar and comfortable with all of that. Now, the second question with the centroid does break apart the insides, and we'll look at that 2-to-1 ratio. So something like T to Z, this distance here is 60. And so if that part is 60, what is this remaining part? Again, this is getting broken into 2/3 to 1/3. And so if this is 60, then the smaller part must be 30. In other words, if I'm looking at this full line here of T to Y with that centroid point Z, this is 2x, this is x. This is 60. This is half of 60. And then later on, it actually might be useful to look at this because I think it's going to ask us for ty as well. That full distance would be 60 plus 30. So I know ty is equal to 90. Okay, so that's kind of one example from start to finish of how you're going to use a median to find the full distance and each individual part. Okay? So if you need to, slow down, rewind it, look at that again. I've got 1 part to 2 parts. Okay, 1 part to 2 parts. And then the full one, literally all I've got to do is add the 2 parts to get the full. Okay, I'm going to go a little bit quicker through the other pieces because it's a very similar setup for the rest of this. X to z right here is going to be 28. So if this is 28, what is the remaining part? Well, I can do 28 times 2, which is 56. 28 times 2, because again, it's a 1 to 2 ratio. So I've got 56 there, which was z to v. We already had zy, that was the 30. And then z to u. I'm sure this will be built off of this. I need z to u. We're given w to z. So if that part here is 25, this part here must be 50. And then similar, what is x to z, x to v? So this full distance here is going to be that 28 plus the 56. So we get the full distance, which is 84. Okay, so a little more complicated. You got to split these into the 1/3, 2/3 ratio. But you know, once you have that, like, build yourself one little piece to it, and then use that kind of repetition over and over again. You should be in good shape. All right, now we're jumping into our circumcenter. Circumcenter is the one that is going to be circumscribed. So you're going to have that circle on the outside. We're right smack in the middle, which means we're equal distance to the 3 vertices, right? Those are all congruent. That's what's helpful. So if one of them is 21, all of them are 21. Okay, so that might be helpful. Let's see, t to u, u to z, there it is. U to z is that question right there, so it would be 21. Okay, t to u's across the top. This actually is very similar to what we did on the centroid as well on the outside. You know, with a circumcenter, it's perpendicular bisectors. So this part is congruent to that part. So if one part is 19, both parts are 19. And then if you add them together, you'll see the full distance here of t to u is 38. How about v to y? So v to y, you know the full thing is 34. Again, this is a midpoint, so we're breaking it up. The little part must be 17. And then v to w. Okay, I'm going to clear some of this real quick. Okay, vw or wv is this part here. Now, I don't have tw, which would be congruent. I don't have tv, which would be double that piece, right, because of the midpoint. So I don't really have anything directly to work with. And so you might feel stuck for a moment, and then remember, oh yeah, this is a right triangle because it's perpendicular. It's a perpendicular bisector that makes the circumcenter. So if I pull out this right triangle with measurements of 15, 21, and some unknown x, let's just call that x for a moment, I know with a right triangle we can use Pythagorean theorem. Okay, so recall that a squared plus b squared equals c squared, where a and b are your sides and c is your hypotenuse. So plug in what we have, x squared plus 15 squared equals 21 squared. x squared plus 225 equals 441. Subtract the 225 from both sides, you end up with 216 left over. How do we undo a square? Square root. So we'll take a square root of both sides here, and we'll see that x is equal to whatever that is, right? Throw that in the calculator. It's more than 196, so 14 point something, probably less than 225, so less than 15. Let's call it 14.7. Test me on a calculator just to make sure you know where that's at. It might be like 14.6 or something, but that's how you would do it. Use your Desmos calculator or your cell phone calculator. So then this is 14 point, let's call it 14.7. So then the last part of this question is saying TV now. So now I do want this full distance. So I can take this 14.7 and multiply by 2 to double it. So this would end up being 29.4 if I used 14.7. So again, double check my math on 14.7 and then multiply that number by 2 to double check my math on TV. Okay, so that is the harder question you can get with these, is it's going to have that Pythagorean theorem. Some of these will be the simple, some of them will be that Pythagorean theorem that's a little more difficult. So here we go. Similar approach. Actually, you know what? Pause me right here for a moment. Try this one on your own, and then come back, play through, and see how you did. All right? So pause. All right, welcome back. Hopefully you actually did that. So if H is the circumcenter here, find all these missing pieces. So again, if this is 13, then this is 13, and this is 13. That's our property. That kind of helps us with all these pieces. We also know that these are midpoints because it's perpendicular bisectors. So this is congruent, this is congruent, this is congruent. And we know that these are perpendicular bisectors. So we know that these little triangles being built are right triangles. So let's go knock out all the elements now, okay? GD. This part here is half of 24, so this must be 12. BC is B to C is 2 of those parts, right? So if this is 7, then this is also 7, and together we would get 14. Keep it color-coded here for you, 14. E to H is this distance here. Okay, so that one I don't know yet. This is going to require some of that Pythagorean theorem. So I do know I have a right triangle. I have a hypotenuse of 13. And I just found, right, from what we were doing there with BC, I just found that E to B is also 7. And so I have 2 parts. Let's call this x for right now. So I have my x squared plus 7 squared equals 13 squared. X squared plus 49 equals 169. X squared equals 120. So then square root of both sides here, x will equal pretty much 11, right? This might be 10.9. It might be close enough to 11 that when you round to the nearest tenth, it is 11. So maybe it's 10.9, but maybe it's 11, whatever that ends up being. Okay. Okay, double check me again on my math. I'm not sure which one it is, but it's really close, because if it was 121, it would be 11, right? So it's really close there. All right, FD is here. Guys, similar approach. We don't have the number directly, but I can pull out this triangle. We've got a distance of 3. We don't know this one, so I'm going to call it y for right now. And then keeping in mind our property, right? We're equidistant to the vertices. So this part was 13. This part is also 13. And so now we have our 3 squared plus y squared equals 13 squared. 9 plus y squared equals 169. Y squared equals 160. Y equals the square root of 160, which you could reduce, right? Just for fun. I know your Algebra 2 teachers would appreciate me showing this, right? So you could put it in reduced radical form if you're doing that, or again, you could put it into the calculator and get a decimal approximation, and this would be like 12.6 maybe? I don't know. Okay, double check my math on that. Use your calculator, 12.6, or leave it in reduced radical form for root 10. I think I've programmed it so it'll accept that answer, because I know our next level teachers, our Algebra 2s, would appreciate that. Okay, all right, last piece here, C to D. Where are we at? C to D. So we just discovered this, so double check me again on my math. Whatever that number is, multiply it by 2. And so if I'm accurate here, we can call this, actually, if you double this is why simplified radical form is nice. You could just multiply this by 2 and call it 8 root 10, right? So that would be the simple one. But if we're doing decimal approximation, double check me. This is most likely 25.2-ish. Again, if that's not working, especially when you hit submit, it says wrong, you know, plus or minus a tenth there, or use the calculator. Actually double check my math, okay? All right, that's your circumcenter. The last kind of mathy piece is the incenter. So now we're equal distance to the sides. This will be similar. There'll be some of these that feel really easy, and then some of these that we'll do with Pythagorean theorem. So NP is here. We know we're equal distance to the sides, so this is also 8. That's your easy one. You know N to K. This is what I was talking about in my ESL students. You might have missed this because I told you to skip through it. But that problem earlier that was doing these angle bisectors, this was showing you that these are congruent triangles. So you actually end up with these corresponding parts of these congruent triangles, or what I think I've called on your note card, the consecutive pieces are congruent. So if this is 17, then this is also 17. Okay, so N to K is 17. That would be another one that would be a fairly easy question. I think these last two are going to use some of your Pythagorean theorem again. Let's find out. All right, so P to K is this distance. Yep. So what we just built here, right? You found 8, you found 17. Now go find that distance. And so you can set up your Pythagorean theorem. So you have your 8 squared plus 17 squared equals, let's just call that x for right now, x squared. So 64 and 17 squared was that? Is that 289? Let's see how good my mental math is today. Add those together, you get 353. Equals x squared. So take the square root of both sides of that. Is that a nice number? Maybe not. Maybe it's around 19 something. Hold on, I'm gonna actually pull a Desmos. All right. Again, if you don't have a calculator, please use Desmos Scientific. I think is a great tool for you to use. So we had 8, whoops. I'm blocking some of my stuff there. There we go. We've got 8 squared plus 17 squared. Let's see how I do. 253. All right. So I was accurate to that point. And then let's take the square root of that number, which for my coders out there, you can just type in ANS. It'll pull up your answer. 253. Oh, it was pretty close. 18.8. Not bad. Okay, coming back here. Put that back down. All right, so this was, there we go. 18.8 is our x value. Okay, so 18.8, and then to find our LO, this part here, this is then again using Pythagorean theorem. You know that this triangle, there's your unknown, let's call it y. We're still equal distance to the side, so that's an 8. And then we have that diagonal 13. So y squared plus 8 squared equals 13 squared. Y squared plus 64 equals 169. Y squared equals 105. So square root of 105, which is what? Roughly 10.2, let's call it. Again, double check me on my math. Or should we, actually, since I pulled it up already, let's go take a look. Let's see what we get. We've got square root of 105. Hey, 10.246957. I was pretty close. 10.2 is correct to the nearest tenth. Okay, so 10.2. Boom. All right. One more. Let's do it. One more mathy one. This one I remember doing this one in class. This one starts with Pythagorean theorem, and then the last two are actually easier. So be prepared for a couple of weird, difficult ones here. So G to D is that part. We know that it is equal in distance to the other elements, like the parts to the sides. We know are equal distance, but we don't have any of them yet. So we got to do Pythagorean theorem. I do have these numbers, so I'm going to use that part of the triangle to help me, because if I can find one of them, I find all of them. So x, 35, 37, and they actually did ask us for GD, so that's helpful. So x squared plus 35 squared equals 37 squared. Those are nice big numbers, aren't they? X squared plus, let's jump back to Desmos. Okay, so we've got 35 squared is 225, 12, 25. 37 squared is 1369. Subtract that from both sides. We end up with x squared equals 144. Oh, that's a nice number. We actually got a Pythagorean triple. X equals 12. Cool. All right. So 12. Okay, BG. B to G is here. So again, we'll pull another triangle out. I know this distance is 6. We just found GD, which will be the same as EG. So this is 12. And then we'll go find B to G, which I'll call Y for right now. Oh, I actually just noticed that's half of that. This is a 30, 60, 90 triangle. It's kind of fun. So you actually, those of you who are comfortable with that or have been taking some trig stuff already might go, oh, that's 6 root 3. It's a simple thing. Anyways, let's go do it if we didn't recognize that. So 6 squared, 12 squared equals y squared, 36, 144, y squared, 180 y squared, and square root of that is I don't know what, 13.6 maybe, I don't know, something like that. Or again, if we did reduced radical form, what could we do? We could do 36 and no. Did I mess that up? No, this should be all right. So this would be 9 and 20, so 3. This is 4 and 5. 6 root 5. Oh, that's not a 30, 60, 90 triangle. That's why. If this was 6 and 12 over here, then that would have been 6 root 3. That's why. That's why my head was off. Good thing I didn't just shortcut it. Would have made a mistake. All right, so throw this in the calculator. I think it's about 13.6. Let's just double check. We've got the square root of, square root of 180. Oh, 13.4. Okay, all right, and then like I said, these last two, these are the easier questions. So F to C is here. We've got congruent consecutive pieces, so this is 35. And then you have the last part here, B to F. B to F is, there's your piece there, so this is also 6. Okay, all right. There's the math stuff. I hope you're feeling good. The last element of this homework quiz is being able to name that center. So you're going to look at the picture, you're going to look at the information, you're going to go back to your note card, you're going to match them up. So when you look at something like this, you're going to say, ooh, those look like angle bisectors. And you're going to look at your note card and be like, oh yeah, angle bisectors are in center. All right, so you're going to be able to identify it that way. Let's say we're looking at this one. You've got, looks like perpendicular, and it looks like it goes through a vertex. So as I look at that, I'm like, oh, those are altitudes. Altitudes are the center, or create the ortho center. All right, so that's kind of what you're trying to do with these. Go ahead and try the other 8 of them, and then hit play and run through this with me. All right, so pause, try on your own, go. All right, welcome back. Here, hopefully you see these tick marks, so you're thinking midpoint to vertex, which we know are medians, and so the median is going to give us the centroid. When we take a look at this one, you go, oh, look, still got tick marks. So this is, again, a midpoint, but this time, ooh, right angles. This must be a perpendicular bisector. Perpendicular bisectors create the circumcenter, okay? Here, you're going to look at this property, like, oh, look, these are all equal distance. So if I'm equal distant to the vertex, this must be my circumcenter. Then you're going to look at this one. You're going to be like, okay, look, I've got a midpoint again to a vertex. So this, once again, must be a centroid. Okay. Here, I can see that I'm equal distance to the sides. Equal distance to the sides would be an incenter. Here, vertex, perpendicular. These are altitudes, so this must be your orthocenter. And the last 2, again, you've got these little markings. You know that this means angle bisector. Angle bisectors create the incenter. And midpoint, perpendicular, so it's a perpendicular bisector. You've got the circumcenter. Okay, that is it. Make sure you hit submit so you can save all your answers. Go back, edit your responses, view your score, make sure you've done well. If you need extra help with something, swing by. Good luck.